Hello friends, I am Manisha Devre, Assistant Professor from KVN Naik College, Nasik. Today we will study lasers and laser applications. The sense associated with eye is known as vision or sight. Light is the agent which stimulates our sense of sight. The eyes convert the incoming light into the electrical signals and convey them to brain. Brain processes the signal causing images or pictures to be created in our mind. The objective of this video is introduction of laser, properties of laser and basic principles of laser. Hopefully learners can understand what is meant by absorption, spontaneous emission and stimulated emission. Lasers truly been one of the greatest invention in 20th century. They have found a variety of uses in electronics, computer hardware, medicine, industries, military and experimental science. The laser stands for light amplification by stimulated emission of radiation. Laser is a device that emits light through the process of optical amplification based on the stimulated emission of electromagnetic radiation. A laser differs from the other sources of light because it emits light coherently. So first of all, we must understand what are the basic properties of laser. First important property is directionality. Laser emits light that is highly directional. Laser light is emitted as a relatively narrow beam in a specific direction, whereas ordinary light, such as light coming from sun, light bulb or candle, emits the light in many directions away from the source. Second important characteristic is coherence. The light from the laser is said to be coherent, which means that the wavelength of the laser light are in phase in time and space. Third important characteristic is monochromatic. The light emitted from laser is monochromatic, that is, it is having one wavelength or one color. In contrast, the ordinary white light is a combination of many different wavelengths or colors. Now we'll study about the structure of atoms, which is very important. Every object in the universe is made up of atoms. Atoms are made up of extremely small particles such as electrons, protons and neutrons. Electrons are the negatively charged particles, whereas the protons are positively charged particles. Neutrons have no charge, hence the neutrons are referred as neutral particles. The strong nuclear force between the protons and neutrons makes them stick together to form the nucleus. Neutrons have no charge, so the overall charge of the nucleus is positive because of the protons. The electrostatic force of attraction between the nucleus and electrons causes the electrons to revolve around the nucleus. The electrons revolving around the nucleus have different energy levels based on the distance from the nucleus. The electrons revolving very close to the nucleus have lowest energy level, whereas the electrons revolving farthest distance from the nucleus have highest energy level. For example, if the lowest energy level is E1, the next energy level is E2 and the next is E3, E4 and so on. The electrons in the lower energy state needs extra energy to jump to the next higher energy state. This energy can be supplied in the form of electric field, heat or light. When the electrons in the lower energy state gain sufficient energy from photons, they jump to the next higher energy state. The electrons in the higher energy state do not stay for a long period. After the short time period, they again fall back to the lower energy level by losing some energy. The electrons in the higher energy level or the higher energy state lose energy in the form of light before they fall back to the lower energy state. The electrons in the higher energy state are known as excited electrons, whereas the electrons in the lower energy states are known as ground state electrons. In lasers, the way light or the photons interact with the atoms play an important role in its operation. The photons interact with in three ways with the atoms. First is absorption of radiation, second is spontaneous emission, third is stimulated emission and fourth one is population inversion. So first of all we will study what is meant by the absorption of radiation or light. The process of absorbing energy from the photons is called as absorption of radiation. It is well known that there are different energy levels in an atom. The electrons that are very close to the nucleus have lowest energy level, whereas the electrons and these electrons are known as ground state electrons. Let us consider the energy level of ground state electrons or the lower energy state electrons, that is E1, and the next higher energy level or the higher energy level is E2. When the ground state electrons or the lower energy state electrons absorb sufficient energy from the photons, they jump to the next higher energy level or the higher energy state E2. In other words, when the ground state electrons absorbs sufficient energy, which is equal to the energy difference between the two energy states, that is E2 minus E1, the electrons jumps from ground state energy level to the excited energy level, that is E2. The electrons in the higher energy level are called as excited electrons. The light or the photon energy applied to the excite the electrons can be mathematically written as h nu, and it is equal to E2 minus E1. H is Planck's constant, nu is the frequency of photon, E1 is the ground state energy, and E2 is the higher state energy. Absorption occurs only if the energy of the photon exactly matches with the difference in the energies between the two electron shells or the orbits. Now our next process is spontaneous emission. The process by which the excited electrons emit photon while falling to the ground level or the lower energy level is called as spontaneous emission. Electrons in the atom absorb energy from the various sources such as heat, electric field or light. When the electrons in the ground state or the lower energy state, that is E1, absorb sufficient energy from photons, they jump to the excited state or the higher energy state. The electrons in the excited state do not stay for a long period because the lifetime of the electrons in the excited state is very small. Hence, after the short period, they fall back to the ground state by releasing energy in the form of photons or light. The energy of the emitted photon is directly proportional to the energy gap of the material. The materials with the large energy gap will emit high energy photon, and the materials with the small energy gap, they will emit low energy photons. The energy of the released photon is equal to the difference in the energies between the two electron orbits. The energy of the excited electrons can also be released in the form of heat. If the excited state electrons release energy in the form of photons falling to the ground state, the process is called as spontaneous emission. Our third important process is stimulated emission. The process by which the electrons in the excited state are stimulated to emit the photons while falling to the ground state or lower energy state, it is called as stimulated emission. Unlike the spontaneous emission, in this process the light energy or the photon energy is supplied to the excited electrons instead of supplying energy to the ground state electrons. The stimulated emission is not a natural process. It is an artificial process. In stimulated emission, the electron in the excited state need not wait for the natural spontaneous emission to occur. An alternative method is used to stimulate the excited electrons to emit photon and fall back to the ground state. The incident photon stimulates or forces the excited electrons to emit the photon and fall into the lower state. The energy of the stimulating or the incident photon must be equal to the energy difference between the two electron shells. In this process, the excited electrons release the additional photon of same energy, same phase and same direction, while they released with the electrons falling into the ground state. In stimulated emission process, each independent photon generates two photons. The photons emitted in the stimulated emission process will travel in the same direction as that of the incident photon. Our next important process is population inversion. Under normal condition, more electrons are in the lower energy state than in the higher energy state. Population inversion is the process of achieving more electrons in the higher energy state as that of lower energy state. In order to achieve the population inversion, we need to supply energy to the laser medium. The process of supplying energy to the laser medium is called as pumping. The source that supplies energy to the laser medium is called as pump source. The type of the pump source used depends upon the laser medium. Different pump sources are used for the different laser mediums to achieve the population inversion. Population inversion is basically achieved when the system of molecules or the atoms have the energy levels with the favorable properties. For example, the upper energy level has a long lifetime, whereas the lower energy level has short lifetime. The electrons in the higher energy state do not stay for a long period. After the very short time period, they fall back to the next lower energy state or the metastable state E2 by releasing the radiation less energy. The metastable state E2 has greater lifetime than the lower energy state. More electrons are accumulated in the energy state E2 than the lower energy state E1. Thus, population inversion is achieved. Thank you.